Hi, and welcome to Meet a Google Researcher, a new series where we get to meet some folks who are advancing the state of the art in helpful technology, tackling some incredibly difficult problems. I'm Drew Calcagno, and I'll be your host. Today, we're going to meet the brains behind what you'll see in language technology. So you might have a voice assistant in your kitchen, or maybe a robotic vacuum in your living room. Maybe you've seen videos of walking or rolling robots before, or perhaps even captained your school's robotics team. But you haven't seen language models embedded in a robot like this before. This is new. And it's very early, but it's a step towards truly helpful and interactive experiences with machines. Sharan Narang and Akansha Chaudhry theorized and coded Palm. It's a new language model that achieves state-of-the-art performance on challenging language modeling tasks. And they partnered with robotics teams at Google Research, as well as teams at Everyday Robots, a learning robot moonshot at Alphabet. What's so amazing here today is that these researchers and their teams have enabled language models to be embedded into something physical that we can see and that we can operate. One of Everyday Robots' helper robots. This is state-of-the-art research. A robot understanding humans' commands with language and then, with robust guardrails in place, performing an action that humans want. And despite huge technological leaps, there's still this fundamental barrier that remains between people and computers, and that's language. But this natural language processing can bridge that gap. And the impact can be seen in digital applications like companies or people trying to organize and understand text at scale, and in physical applications too, like with one of these helper robots. Welcome.
Thank you.
Thank you so much for coming here. Could you tell me a little bit about yourself, Akansha?
I work at Google Research, and I work on designing efficient strategies for both the training and inference of language models and models that are more capable.
Amazing. And Sharan, tell me about you.
Yeah, I work at language technologies at Google, and my goal is to build more capable and stronger language models.
Outstanding. And so let's start from the top. Sharan, what is Palm and what are language models?
Yeah, so I'll start from language models. So language models are typically trained to predict the next word in a sequence, and they do this by building a probability distribution of words or sequences of words. Prior to neural networks, we had n-gram-based approaches that essentially counted the frequency of words or word sequences, and this allowed them to build a probability distribution. More recently, we've seen deep neural networks are tremendously capable at doing this by just training on vast amount of data, and they're able to solve many tasks at once. PALM stands for Pathways Language Model, and it's essentially a deep neural network trained on the next word prediction task. And we've scaled the language model to larger sizes, and we've seen that it's actually capable of solving many more tasks than previous models were able to.
Wow. And so you described that it can solve all these different tasks, more than any previous model. But what else makes this so special today?
So the really novel thing about Palm is that it's able to solve tasks that it wasn't explicitly trained on. So, for example, Palm is able to explain jokes, and we noticed that this wasn't in the training set at all. Like, we didn't show it a joke and ask it to generate an explanation, but Palm learned it from the training data and is able to do so. Similarly, with translation or multilingual question answering, we didn't really have that in the training process, but through just seeing multiple documents on the web, it's able to learn this and generate answers in different languages as well. Just with a handful of examples, we're actually able to uncover new capabilities of Palm and see what it's really capable of.
I think it needs to explain my jokes. I'm not terribly good at this. Akansha, you also work in artificial intelligence. This is such a broad field. You work in language models. So orient me around your work in this space in general.
I think what's really exciting about Palm is that with the scale of Palm, we have seen some breakthrough capabilities emerge. And one of the breakthrough capabilities is that with the model scale of Palm combined with some prompting techniques called inner monologue or chain of thought or scratchpad prompting, what we're seeing is that the model is able to show intermediate reasoning steps. Now, let me explain what that means. So if you were solving a math problem, typically the teacher would explain to you what were the intermediate steps and then give you the final answer. And that would be really helpful for you to learn. Now, if you give a handful of such examples to the model, and you give it a math problem, the model also outputs the set of explanations, like what are the intermediate reasoning steps before it gives the answer. Now, that was just for the math problem, right? Now, this extends to common sense reasoning problems, and it extends even in the domain of robotics, for example, which is what we are seeing today. If you ask the robot to go get you an apple, it can break it down into sequential set of actions, like I have to first find an apple, then I have to go to that table then I have to pick up the apple, and so on. And this is really special, and it has tremendous applications downstream in robotics, in code completion tasks, so assistive coding, assisting the humans to code, in education domains. So there are likely to be a lot of fun applications downstream.
Yeah, I can only imagine how many applications there will be, but I'd love to get excited about this robotics one. So you mentioned robot being able to grab an apple and bring it to me. But where are we in this language and robotics story?
One of the challenges in that in robotics has always been that you have to really pre-program them with a sequential set of instructions, and you have to learn the APIs that are available on these machines so that you can give it the set of instructions. And it's very limiting in terms of I have to first learn that language, and then it can only do a pre-programmed set of tasks. What's really exciting with Palm is that now we have moved to a set of capabilities where you can talk to the robot in natural language. So, for example, that example of telling the robot to go find an apple, it's a natural language, and then Palm can spit out a set of sequential actions that the robot could take to complete that task. And that's just fundamentally so different from just pre-programming and me knowing exactly step by step what the robot needs to do. And if I miss a step, then the robot would not quite get to the task.
Right. And so it's learning, it's reasoning through these, inferring what you meant, finding the definitions of what you were trying to say and returning it. And it can do it in a number of different languages, it sounds like.
Yeah, and it can even incorporate feedback. Like it's not able to complete an action. It can take the user feedback and then go fix that.
And when it's fixing itself, you're thinking about reasoning. And Sharon, what are the implications of reasoning in this type of model?
Language, if you think about it, is really the interface with which we communicate and interact with our environment. And we're seeing as these language models get more capable, we're seeing that they're being used to enable different domains as well. A recent example is where a language model and an image model combine to produce really compelling images from natural language to text. And robotics really extend this to another level because it's actually interacting with the physical world, not just with computers. And by offloading most of the reasoning and planning capabilities to the language model, the robotics can focus on challenging tasks like mapping, navigation, object manipulation. So essentially, language models allow the robotics domain to focus on solving tasks, and the reasoning is handled by them. So you can imagine a more complex task is broken down into smaller tasks which the robots can solve. And now you have this, array of tasks which can be combined in various different ways to solve a complicated task one day, like perhaps baking a cake or something. We're not there yet, but hopefully sometime in the future.
Fair enough. I imagine that as you think about all these future tasks, you're both thinking about societal implications. So what does that look like to you, Akansha?
So building AI responsibility is core to the mission of Google. And this showed up in our process all the way from how we curate the data set, to how we train the model, to how we deploy this model to any downstream tasks. For example, in dataset curation aspect of things, we spend a lot of time making sure that the model is fair, inclusive, multilingual, and making sure it's trained on 100 plus languages so that it can serve populations around the world, and also remove anything that might cause harms. In model training and model deployment, we try to assess if there might be any specific risks that we need to be careful about. And then in terms of deployment, I'll give you an example from the robotics domain. So The model outputs are strictly vetted, and we make sure that the words there's a software layer, there are safety guardrails in place where the words are vetted and made sure that there's no action that the robot can take unless the safety constraints have been met.
And so when you both are thinking about these safety layers, the guardrails, I imagine that it's ever evolving. And is there always someone really conscious of these? How are you developing them, Sharon, that they are perpetually being able to be updated?
So yeah, I think as Akanksha touched upon this, safety and responsibility is like a core part of the pipeline throughout the development process. And we're also engaging with experts in the field to make sure that we're informed of all the new developments and
Like yourselves.
but it requires a lot of thought and judiciousness to think about this and make sure that anything that we build is actually safe and fair to everybody there. So we're working closely with all the experts in the field and trying to build scalable solutions for these problems.
And for a language model, could that be making sure a slur doesn't come through? What else would that look like?
So I think in the domain of language models, there's the fairness and inclusivity aspects. There is the ensuring that the data that these models sees and the outputs that it generates are in the domain that are not risky in any way. So I think the specific example would be that if you find an apple, you will not go see your robot go pick up something that is not allowed for it to go pick up.
So just one more example is you mentioned slur. That's one thing just for the plain language model we handle. Another thing is pronouns, for example, right? Certain pronouns get associated with certain occupations and genders, and we need to do more there. And we're already doing quite a bit to make sure that it's fair to all genders and also religions and all these kind of sensitive topics that we really need to think through, because we need to make sure the model is able to be fair and unbiased to everybody.
That is so powerful. And I imagine that it's difficult to use data about the world that we are in versus honing towards the world that is more equitable and inclusive going forward.
I will add, this is an evolving area, so I think I think our approach is to go slowly, and in research we are trying to push the state of the art, go slowly and learn, and incorporate that feedback.
Yeah, finding the right pace, it's tough.
And going slowly also has the added advantage that we can actually build scalable solutions. So it's not just solving one aspect of fairness or safety, but we're trying to build something that will scale and be very inclusive.
I'd like to kind of wind the clock back a little bit to when you two were growing up. What's something from your childhood that might have inspired you or made you successful in this project, Sharon?
So yeah, I grew up in India, and people in India speak many languages and dialects. Just in my neighborhood, we had people speaking 7 or 8 languages. So it was pretty diverse in many ways. And that was one of the motivations of training Palm is I wanted to make sure it was multilingual so it could be served with to many users. So essentially we included vast variety of languages. We can do more, but I think it's a really great start. And with this collaboration with robotics, I'm really hopeful that one day, we can tell a robot to get a coffee in Hindi and many other languages.
That's so exciting. And Akanksha, do you have a similar story? What's something from your childhood?
Well, I grew up and I was fascinated by computers when I was growing up. So I would spend hours learning all the languages that were in my childhood. You might not have heard of them. Spreadsheets back then were Lotus 1, 2, 3. So go fiddle around, figure out how to program them. And then there was logo, move a turtle around. This was like me being really young. And then there was the typical learn Fortran and COBOL and BASIC. And so it was a ton of languages that I had to learn to program each of these different tasks. And now what's exciting and what's really inspired me is that now I don't have to go learn all these languages. Right. I can talk to computers like I can talk to humans. So this is really a turning point in the history of human-computer, human-machine interaction.
I'm terribly excited about it. Yeah. And now when we think about the future, Sharon, what's the future looking like for these types of models and our interaction with them?
So yeah, it's a really exciting time. We're seeing language models become more capable and are able to solve many tasks. They're able to answer questions for users. They're able to translate from one language to another. They're able to summarize documents, just to name a few. And we're also seeing how the impact of language models is being seen in other fields like code generation or image generation, and as we see today, robotics. So it's really exciting to see all the space of progress in language models. However, as we touched upon a little bit earlier, it's important to be thoughtful and judicious at every single point and build technologies that will serve many users across the globe. And we're actually being really thoughtful and slow about these things. We want to take a measured approach and build solutions that will really scale and allow us to build fair and balanced language models.
Well, Akansha, Sharon, thank you so very much. I'm illuminated by all of this, and I cannot wait to see what's coming next. So thank you for coming.
Thanks for
Thank you
having
so
us.
much.
It was a pleasure.
Great.